mole calculations, that how will we find the number of moles, right? Number of moles. In the previous video, I told you 3 formulas. I hope you all remember those formulas. The first formula was number of mole is equal to mass in gram divided by molar mass. This was the first formula. The second formula was that number of mole is equal to number of particles divided by Avogadro number. And what was the value of Avogadro number? 6.023 multiplied by 10 raised to power 23. Right? How can you learn this? Learn only 6.0, right? And 2.3 over here. This 2.3 is also at the top of the power of 10. Right? So you have to learn 6.023 multiplied by 10 raised to power. The same last two digit will be on the power of 10. So in this way you can learn the Avogadro number. And what was the third formula? Third formula was related to the number of moles and volume in STP. We learned that number of moles is equal to volume of gas at STP divided by molar volume. Molar volume at STP. What was STP? STP was standard temperature and pressure. And what were the values of STP? I already told you in the previous video. But let me also tell you the value of molar volume. What was it? It was 22.4 dm cube per mole. Now let us go towards the mole calculations. The very basic things that we should know for calculating the number of mole is the molar mass. Molar mass. Molar mass for which formula? For this one. And also in this case, in case number 2, we will already be given the number of particles. If we are not given the number of particles, we will know the number of moles, and with the help of any of them we can find the other number. First we will solve the numericals regarding to this formula. So for this we should know about the molar mass. Also studied the molar mass in our first lecture, but let me again briefly tell you that how will we find the molar mass. In the previous video I told you that first you have to write the formula. Let us take the water molecule. Right? Now we should know the atomic masses. Okay? What is the atomic mass of oxygen? It is 16. And what is the atomic mass of hydrogen? It is 1. Now hydrogen is equal to, how many hydrogens are present? 2. And 2 multiplied by what is the atomic number? 1. It will be equal to 2. Oxygen is equal to, what is the atomic mass? 16. Or we can write the number of oxygen or atomic mass, whatever before. So here I am writing the number of oxygen present multiplied by what is the atomic mass? 16. So it will be equal to 16. When we will add both of them, we will get an answer 18. And when we will write it in terms of molar mass, we will write gram per mole. Right? So this will be the molar mass, and this is how we will calculate the molar mass of all the other substance. Now before starting the mole calculations, I would like to tell you that how you will attempt these numericals in your exams. First, you will write the question, then you will give the heading of data. Okay? Now in the question there will be one thing that will be required, like you have to find the number of moles or you have to find the number of particles, etc. So you will give the heading of required. Okay. Then after writing this, you will give the heading of solution. And after solution, directly give the heading of formula. After doing all the calculations, give the heading of result. Now the first numerical that I am going to discuss is So how will we find the number of moles in 2 gram of oxygen? We know the formula that number of moles is equal to mass in gram divided by molar mass. So in this case, what we have to find? We have to find the number of moles, and we already know the mass in gram, and we can find the molar mass by ourselves, right? Now let us first find the molar mass. What is the atomic mass of oxygen? It is 16. And how many oxygens are present? 2. So 2 multiplied by 16, which will be equal to 32. And for molar mass, we will write the unit gram per mole. Let us see, the number of moles will be equal to 2 gram divided by 32. Here n will be equal to, after cutting it, we will come to know that number of moles will be equal to 1 by 16. Okay, and we will write the unit mole. So this is how we will find the number of moles. You can further divide it and write the answer in decimal form as well. Now the next example that I am going to discuss is that how many number of moles are present in 60 gram of sodium hydroxide. For this we will use the same formula, that is number of moles will be equal to mass in gram divided by molar mass. First we will find the molar mass. For the molar mass, we know that we should know the atomic masses. The atomic mass of sodium is 23. Right? Let me write over here 23. The atomic mass of oxygen is 16 and atomic mass of hydrogen is 1. Okay? These are the atomic masses. Now, molar mass, how many sodium is present? 1. So we will write, and 1 multiplied by what is the atomic mass? 23. Okay? How many oxygen is present? 1. And what is the atomic mass? 16. Now the last one is hydrogen. How many hydrogens are present? 1. And what is the atomic mass? 1. Right? We will write it in this way. Now when we will add all these, we will get an answer 23 plus 16 plus 1. And this all when we will add, we will get an answer 40. And when we will write over here gram per mole, then this will be the molar mass of sodium hydroxide. Now what we have to find? We have to find the number of moles. Now we have the mass over here. Now we already calculated the molar mass. Now we will put the values. Number of mole will be equal to mass in gram, which is 60 gram divided by 40 gram per mole. This gram and gram will cancel each other, and this 0 and 0 we can cancel it, or we can directly divide them. Then we will be left with 6 and 4. When we will divide these, we will get an answer 1.5 mole. Okay, so number of moles, we get to know how many number of moles are present. 1.5 moles. Now let us go on to the next numerical. I hope you already understood the first formula, that how will you do the calculations, but let us see that how can we find the number of moles from the mass given. How much mass is present in 5 moles of calcium carbonate? In this case, we are already having the moles and we have to find the mass. Okay, the formula will remain the same. It will be number of moles will be equal to mass in gram divided by molar mass. Okay, now what will happen? That we will rearrange this formula. This mass will stay in its place and this molar mass will go on the other side. It is in division form. On the other side, it will multiply with the molar mass. So after rearranging the formula, it will be in this way. Number of moles multiplied by molar mass, which will be equal to mass in gram. Now we have this formula, which is the rearranged form of the main formula. we are already having the number of moles and we can find the molar mass, right? Note this formula. Let's first calculate the molar mass. Molar mass of calcium carbonate. Atomic mass of calcium is 40, atomic mass of carbon is 12, and atomic mass of oxygen is 16. Till now at least you have learned the atomic mass of oxygen because we have used it in many examples. So 40, 12 and 16. How many calciums are present? Only one. So 1 multiplied by 40. How many carbon is present? 1. We will put the plus sign over here and 1 multiply by 12. Then how many oxygens are present? We will put the plus sign and then we will write 3 oxygens which will multiply with the atomic mass, that is 16. When we will multiply and add all these, we will get an answer 100 gram per mole. The formula that we rearranged was that mass is equal to number of mole multiplied by molar mass. Now, number of moles is already present in the question, that is 0.5. We will multiply it with the molar mass, that is 100 gram per mole. Okay? No. Here it's mole. You can see over here that if we write it in the other form, it's like this, 100 gram per mole, right? So this mole and this mole will cancel each other and we will be left with gram. So after calculating this, we will get an answer 50 grams. So mass in gram that we found is 50 grams in 0.5 moles of calcium carbonate. Now the next numerical that I am going to start is that in a certain experiment 8.50 multiplied by 10 raised to power 25 molecules of water were used. Calculate the number of moles of water. In this case we are given the number of molecules. So which formula we will use? We will use the formula that number of moles is equal to number of particles. We are given with number of molecules, so we can write here number of molecules divided by Avogadro number, right? Now when we will put the values, we will get the number of moles. So number of molecules is equal to 8.50 multiplied by 10 raised to power 25 divided by 6.023 multiplied by 10 raised to power 23. When you will divide these, you will get an answer 1.41. Okay, and this 10 raised to power 23 will go on the upper side and it will be like 10 raised to power 25 minus 10 raised to power 23. Here it is in plus form. So when it will go on the upper part, it will be in minus form. So 25 minus 23, we will get 10 raised to power 2. And as we have to find the number of moles, so we will write over here 10 raised to power 2 moles. So this will be the number of moles present in 8.50 multiplied by 10 raised to power 25 molecules. Now in this example, see that how many formula units are present in 125 gram of hydrated copper sulfate. It is not simple copper sulfate CuSO4, it is in hydrated form. Have a look that we are given the mass. We are not given the moles, from which we could easily calculate the formula unit. In the formula of number of moles, which is equal to number of formula units, here we can write in place of particles formula unit divided by Avogadro number. So we are not given the number of moles, we are given mass in gram. If we were given the number of moles, we could easily find the number of formula units by rearranging the formula and taking the Avogadro number on the other side, where it would multiply with number of moles. So from this formula, we can see one thing, that we have to find the number of moles. So we will convert this mass in gram to the number of moles. First of all, we will find the number of moles, which is equal to mass in gram divided by molar mass. We know the mass in gram, which is equal to 125. And we have to find the molar mass. So we have to find the molar mass of hydrated copper sulfate. Let us first find the molar mass. Molar mass is equal to, first we will write the atomic masses of all. The atomic mass of copper 64, the atomic mass of sulfur is equal to 32, the atomic mass of oxygen is equal to 16, and we know the atomic mass of hydrogen, which is equal to 1. So let's calculate the formula mass. We will start with copper. How many copper are present? 1. So 1 multiplied by 64. Then sulfur. How many sulfur are present? 1. Plus 32 multiplied by 1 or 1 multiplied by 32 plus oxygen. How many oxygens are present? 4. 4 multiplied by 16. Then plus sign and 5. 5 of water molecule. After this we will write the number of hydrogens present, that are 2, multiplied by its atomic mass, that is 1. Then we will add, what is the atomic mass of oxygen? It is 16. So in this case what we will do, that we will multiply this and this. We will write their answers, plus we will write 5 in its place and we will multiply first this and plus 16. Now we will first calculate this bracket and it will be 5 into 18. 16 plus 2, 18. After adding all these values, you will get an answer that will be equal to 250. Okay, 250 gram per mole. So now we calculated the molar mass and we know the mass in grams. So now we can calculate the number of moles. Remember one thing, that if you want to find the formula mass or molecular mass, you will go with the similar procedure of adding and multiplying their atomic masses. Then you will write the unit AMU. Okay. Now for copper the answer was 250. So if you will write in the form of formula unit, you will write 250 AMU. And then you will write a statement that when AMU is replaced by gram per mole, then that answer will become the molar mass. Okay. Now we have find the molar mass. So number of moles was equal to mass in gram divided by molar mass. Molar mass was equal to 250 gram per mole. So we will write over here 125 gram divided by 250 gram per mole. Then we will have an answer of 0.5 mole. Okay. Now we have the number of moles. So now we can calculate the formula unit present in 125 gram or 0.5 moles of hydrated copper sulfate. The rearranged formula that we did was equal to number of moles multiplied by Avogadro number, which is equal to number of formula unit. Right? So now in this case we are having now number of moles, which is equal to 0.5 multiplied by Avogadro number. So when you will calculate this, you will get an answer of 3.011 multiplied by 10 raised to power 23. So this is the number of formula unit present in 125 gram of hydrated copper sulfate. First of all, remember one thing, that in all the conversions, when you will be given any substance in gram, right, means the mass will be given, you will convert that mass into moles first. In mole to mole conversion, you will be given the reactant or the substance in moles and you have to find the other in moles as well. Now let us understand this with the help of example. First question that I am going to discuss is, here they say that oxygen can be prepared by the decomposition of potassium chlorate. Now in this statement what they are saying that by the decomposition reaction of potassium chlorate with other product, the other product whatever it is formed, oxygen will be prepared as well. Okay. Now the main question is that how many moles of O2 can be prepared by taking 10 moles of KClO3 potassium chlorate. Now let us see the reaction. Remember that the equation that we will write should be balanced because it is important for the further solution. Now we have the equation that is, now the reaction is 2KClO3. It is decomposing and converting into KCl. Now in this reaction KClO3 is decomposing, KCl is formed, and with KCl oxygen is also formed. Now first of all we will see that what they are saying in the question. See over here how many moles we used for preparing 3 moles of oxygen, 2 moles of KClO3. And what they are saying in the question, how many moles of oxygen can be prepared by taking 10 moles of KClO3. Means in place of 2 we will take 10 moles of KClO3. But then how many oxygens will be formed? So this was the reaction. From the reaction we will compare KClO3 and O2. We will write 2 mole of KClO3 and 3 mole of. Now what they said in the reaction that we are having 10 moles of KClO3, then how many moles of O2 will be formed? So here we will write 10 mole of KClO3 and we will write over here X. We have to find this value. So what we will do cross multiplication. This will multiply with this and this will multiply with this value. So now how we will write the equation? We will write it as 2 mole of KClO3 multiply by X, which will be equal to 3 moles of O2 multiply by 10 mole of KClO3. Now X will stay in its place and we will write in a statement that dividing 2 mole of KClO3 on both sides. Now we will write 2 mole of KClO3 multiply by X divided by 2 mole of KClO3, which will be equal to, we will rewrite these values and we will divide it by 2 mole of KClO3. Now here they both will cancel each other and from here only mole of KClO3 will cancel the mole of KClO3. Now what will be left? X is equal to 3 mole of O2 multiplied by 10 divided by 2. When you will calculate this, you will get an answer 15 mole of O2. So in the result you can write that 15 mole of O2 by decomposition of 10 mole of KClO3. Now let us discuss another example from your exercise so that your concept will be cleared more. This is the balanced chemical equation. How many moles of H2O will be obtained by burning 5.6 moles of O2 in an excess of H2. Let me solve this question with headings. First we will give the heading of data and then given. Then I will write over here required. So what is given? Number of moles of O2, which is equal to 5.6. And what is required? What they say, how many moles of H2O can be obtained. So we have to find number of moles of H2O. Right? We will also use the same method over here. Now here we will compare this oxygen and water. 1 mole of O2 equivalent to 2 mole of H2O. So how many moles of O2 we are given? So if we have 5.6 mole of O2, then they say how many moles of H2O can be prepared. We will simply do cross multiplication. Right? So we will write over here 1 mole of O2 multiply by X equal to 2 mole of H2O multiply by 5.6 mole of O2. We have done the cross multiplication. So now what will happen? X will stay in its place and we will divide 1 mole of O2 on both sides. So we will write in a statement dividing 1 mole of on both sides. So let's divide it. We will again write 1 mole of O2 multiply by X divided by 1 mole of O2. Then we will write the other side 2 mole of H2O multiply by 5.6 mole of O2 divided by 1 mole of O2. Now what will happen? They both will cancel each other. And from here only mole of O2 will cancel mole of O2. So what will be left? X is equal to 2 mole of H2O multiply by 5.6. If you want to write divided by 1 again you can write, but there is no need of writing divided by 1. So when we will multiply this, we will get an answer 11.6 mole H2O. So in the result, we will write that 11 will get 11.2 mole of H2O. So in the result, you will write 11.2 moles of H2O are obtained. Mole to mass conversion. In this case, what we do that if mole of one substance is given, then we can easily find the mass of the other substance. Okay, now how we will do it? Let us understand this with the help of examples. The first example that I am going to discuss is how many grams of carbon dioxide can be produced by thermally decomposing 8.8 moles of ZnCO3. We will write the balanced chemical equation. It will be in this way. It will decompose and it will produce ZnO and carbon dioxide in gaseous form. So, how many moles of zinc carbonates are used to produce 1 mole of carbon dioxide? Only 1 mole. So we will write over here that 1 mole of zinc carbonate and 1 mole of carbon dioxide. Right now in the question what they say that if we use 8.8 moles of zinc carbonate, then how many grams of carbon dioxide will be produced. First we will find the number of mole for the carbon dioxide, then we will convert that moles into grams. So first let us do the same calculation as we did for the mole to mole conversion. Here we will write 8.8 mole of zinc carbonate, which will be equal to x, right? Now what we will do over here, we will do cross multiplication. After doing the cross multiplication, we will get 1 mole of zinc carbonate multiplied by x, which will be equal to 1 mole of carbon dioxide multiplied by 8.8 mole of zinc carbonate. Again what we will do that x will stay in its place and we will write in a statement that dividing 1 mole of zinc carbonate on both sides. What will be the equation then? 1 mole of zinc carbonate multiplied by x, which will be equal to 1 mole of carbon dioxide multiplied by 8.8 mole of zinc carbonate. Now we are dividing the 1 mole of zinc carbonate on both sides. So we will write over here 1 mole of zinc carbonate and we will also write over here 1 mole of zinc carbonate. Have a look that this 1 mole of zinc carbonate will cancel this 1 mole of zinc carbonate, and from here only mole of zinc carbonate will cancel the mole of zinc carbonate. Now when we will calculate this 1 multiplied by 8.8 divided by 1, we will get an answer 8.8 mole of carbon dioxide. Now in the question what they asked about that how many grams of carbon dioxide will be produced from 8.8 moles of zinc carbonate. Now what we are having here? We are having the moles of carbon dioxide. So now we will convert these moles into gram. What was the formula? Number of mole is equal to mass in gram divided by molar mass. We have to find the molar mass of carbon dioxide, right? So let us find it. Carbon dioxide, we should know the atomic masses. The atomic mass of carbon is 12 and atomic mass of oxygen is 16. So we will write over here, we are having how many carbons? 1 multiplied by 12 plus how many oxygens we are having? 2 multiplied by 16, right? So we will get an answer 12 plus 32, and when we will calculate this we will get an answer 44 gram per mole, right? Now first of all what we will do, we will rearrange this formula. When we will rearrange this formula, we will put the value of number of moles and molar mass, and we will get the value of mass in gram. Here we will write that mass is equal to number of moles multiplied by molar mass. Number of mole was 8.8 mole multiplied by molar mass. Molar mass is equal to 44 gram per mole. This mole and mole will cancel each other and we will get 387.2 gram. The statement that we can write in our result is 387.2 gram of carbon dioxide can be produced by thermally decomposing 8.8 moles of zinc carbonate. So this is how we did the mole to mass conversion. I hope you all understood. Mass to mole conversion means we are given the mass and we will calculate the moles. Now the question is, how many moles of NaCl are produced from 15.5 gram of HCl? According to the neutralization reaction. So we have this reaction. In the previous video I told you that in these questions, if you are given anything in mass, first of all you will convert that into moles. So here first you will convert 15.5 gram into moles. So now how you will convert it? The formula is number of mole is equal to mass in gram divided by molar mass. Which thing is given in gram? 15.5 gram of HCl. So here we have to find first the molar mass of HCl, right? So what is the atomic mass of hydrogen? 1. And what is the atomic mass of chlorine? 35.5. And how many hydrogens are present? 1. And how many chlorines are present? Only 1. So they both will add and we will get the molar mass as 36.5 gram per mole. Right? So this is the molar mass of HCl. Now let us calculate the number of moles of HCl. Now how much mass is given? 15.5. And what is the molar mass? 36.5. And from here we will cancel the gram and gram. So we will get an answer from here 0.425. So now we will calculate the moles of NaCl from the moles of HCl. Now first of all see how many moles of HCl reacted with NaOH to form NaCl. Only 1, right? And how many NaCl are produced? Only 1 mole. So we can write over here 1 mole of HCl equivalent to 1 mole of NaCl. We will write over here 0.425 mole of HCl is equal to X. Now what we will do over here? We will do the cross multiplication. We will write over here 1 mole of HCl multiplied by X, which will be equal to 1 mole of NaCl multiplied by 0.425 mole of HCl. X will stay in its place and we will divide 1 mole of HCl on both sides. So we will write in a statement dividing 1 mole of HCl both sides by 1 mole of HCl, right? Now they both will cancel each other and we will divide it over here as well. We will get 1 mole of HCl, right? We will write over here 1 mole of HCl. Now here we are left with X only, and from here see over here it's 1 and 1. So when we will multiply 0.425 with 1 and divide by 1, we will get the answer 0.425. And what are cancelling each other? Mole of HCl is cancelling the mole of HCl. From here we got our answer, that is 0.425 mole of NaCl. When you will multiply you will get the answer. I will rewrite over here 0.425 mole of answer. 15.5 gram of HCl produced 0.425 mole of NaCl. I hope you all understood this example as well. Now the question is, how many moles of O2 would be needed to react with 58.5 gram of H2 to form H2O? Here we are dealing with H2 and O2. They say that how many moles of O2 would be required if we use 58.5 gram of H2, right? So First, what we will do that we will convert this mass into moles. So what is the formula? Formula is number of mole is equal to mass in gram divided by molar mass. Mass is equal to 58.5 gram divided by. We have to find the molar mass of H2. How many H we are having? 2. And what is its atomic mass? 1. So we are having molar mass 2 gram per mole. So here we will write 2 gram per mole. And after calculating it, we will get an answer 29.25 mole. So according to the equation, in the question it was 2 mole of H2 and 1 mole of O2. So they are saying in the question that if we are using 58.5 gram of H2 which we converted into mole, that is 29.25 mole, then how many mole of oxygen will be used for preparing H2O or for forming H2O? So we wrote here, according to the equation, 2 mole of H2 equivalent to 1 mole of O2. Right? 2 mole of H2 equivalent to 1 mole of O2. Then we wrote here 29.25 mole of H2 is equal to X. So we will do cross multiplication. After doing the cross multiplication, we will get this equation as 2 mole of H2 multiplied by X, which will be equal to 1 mole of O2 multiplied by 29.25 mole of H2. Now X will stay in its place and we will divide 2 mole of H2 on both sides. 2 mole of H2 multiplied by X divided by 2 mole of H2, which will be equal to, we will write the above values and we will divide it by 2 mole of H2. Here see that they both will cancel each other, and from here mole of H2 and mole of H2 will cancel each other. After dividing we will get, and in place of X we can write NO2, number of moles of O2. I hope you all understood, and if you have any question then let me know in the comments below.